Okay, so we're going to look at solving simultaneous equations, but this time one of them is a quadratic and one of them is a linear. Okay, so obviously if it's got some sort of, well, maybe not obviously actually, if it's got some sort of x squared in, that means it's a quadratic, and if it hasn't, if it's just y equals x blah blah blah, then it is a linear. Okay, now what we are doing when we are solving simultaneous equations is we are drawing the graphs. We're not actually going to do this, but this is what you're doing when you get to your answer. What you're actually doing, we could show graphically, okay? And if we were going to draw this x squared plus y squared, that would be a circle. Okay, so this would be the equation x squared plus y squared equals 29. It would look like a circle. And this is a straight line because it's a linear graph. Okay, so what we are actually working out, y minus x equals 3. What we're actually working out when we are solving simultaneous equations is the points where these two graphs cross. Okay, now points are given as coordinates, and the coordinates have got an x value and a y value, and so both of these coordinates have an x value and a y value. So what should happen, or will probably happen, although not always, but that's fine, we don't need to worry about that. What will normally happen is when you solve an equation, a pair of simultaneous equations where one's a quadratic and one is a linear, you will end up with two values of x and two values of y. Okay? Right, so we're going to, don't worry if this bit's kind of doesn't make sense to you, okay? That bit's not that as important as being able to actually solve them. Okay, but just so you understand why we're doing this, what the point of a simultaneous equation is, that is the point of a simultaneous equation. Okay, so what we are going to do is we're going to take our equations and we are going to label them 1 and 2. You are then going to take normally the linear one and you're going to make it so that it's either x equals or y equals. Now the easiest way to do that in this one is to add x to both sides so that you've got y equals x plus 3. Okay, so now that is in the form y equals. You want to make it either y equals or x equals because then the next bit becomes easier. Okay, so that is our equation 2. Our equation 2 is y equals x plus 3, and our equation 1 is x squared plus y squared equals 29. Then we're going to use a method called substitution, and we are going to substitute our linear equation, so the one that's either x equals or y equals, into our quadratic equation. Okay, so we're going to substitute this equation into our top equation. So what that means is, because our linear one is y equals x plus 3, we've got an expression for y. So wherever we see a y in our quadratic one, instead of writing a y, we're going to write x plus 3. Okay, so let's take our quadratic one. So we've got x squared plus, and then it should be y squared, but we're not going to say y squared, we're going to substitute it for x plus 3. And we've got to square all of y, so that means we have to square all of x plus 3, and then we've still got the 29 on the end. Okay, now hopefully you recall that when you square a bracket, that means you times it by itself. So we've got x plus 3 equals 29. You then can expand this bracket. So when you expand the bracket, if you need to do a grid, that's absolutely fine. If you don't need to do a grid and you do your little banana method like this, that's fine. If you do it in your head, it's also fine as long as you get it correct. Okay, so I've expanded that bracket. And then we need to tidy. So we've got x squared plus x squared, so that will be 2x squared. We've got 3x, and we add 3x, which gives us 6x. We've got 9, and then on the end we have 29. Okay, now this is a quadratic equation because it's got an x squared in it. And in order to solve quadratics, it must equal 0. So to get this to equal 0, we are going to subtract 29 from both sides of our equation so that it equals 0. And when we do that, 9 take away 29 is minus 20. Okay? We have then got to factorise it. Okay, we have then got to factorise it. Now, here's a little tip, but it only works okay, when it equals 0. So you can't do this willy-nilly. It only works when it equals 0. If all of your things, all of your parts of your quadratic are divisible by a number and it equals 0, you can divide through by that number to make it easier. So all of these are divisible by 2. So I could divide by 2, everything by 2 here, and it will not change my answer. Okay, so if you want to, you can divide through by something. If you can, divide each bit by all of them. If it ends up being a fraction or a decimal, don't do that, because then your factorising will be messed up. Okay, now we've done quite a lot of work on quadratics. So once we've got a quadratic, we know that to solve a quadratic, I have to factorise. I mean, you could use the formula, but we're going to assume this is in a non-calculator. Okay, so when I have to factorise this, I've got to find two numbers that times to get minus 10 and add to get 3. I don't need to worry about this number on the front because that's a 1. So two numbers that times to get minus 10 and add to get 3 are going to be minus 2 and positive 5. Okay, so when I put that into brackets, I've got x minus 2, x plus 5, and that must equal 0. Then you're going to take each bracket and make it equal to 0. So x minus 2 equals 0, x plus 5 equals 0. We're then trying to find what x is. So we're going to add 2 to both sides to give us x equals 2. And we're going to subtract 5 from both sides to give us x equals minus 5. Okay, what have we done? We have solved it. We have solved it simultaneously to find our values of x. We ended up with 2 values of x, which is what we were expecting, because when we plotted it, or when we sketched it, we think it's probably going to intersect it twice. So we've got an x here and an x here. Here's our 2x values, 2 and minus 5. Now we have not finished yet because we need to find out our y values. Now just like with normal simultaneous equations, once you found out your x values, you then need to substitute them in to find your y values. So the easiest thing to do is to substitute your x values into your linear equation. So the equation that I called 2 up here. So it could be either this top one, but the even easier one to substitute them into would be this one, the y equals x plus 3, because then it's already written as y equals. So then you get y equals, and then you just shove your value of x in. Okay, so I'm going to split this in half so that you can see that we're doing it with the 2 and then we're doing it with the minus 5. So we're going to sub x equals 2 into equation 2, which is y equals x plus 3. So we've got y equals, and then our x is 2, so y equals x 2 plus 3, so that makes y equals 5. And then same over here, we're going to sub x equals minus 5 into equation 2. The equation 2 was y equals x plus 3. So our x is now minus 5, so we've got minus 5 plus 3, minus 5 plus 3 is minus 2. So our solutions are, to the simultaneous equations, x equals 2 when y equals 5, and x equals minus 5 when y equals minus 2. If you wanted to write them as coordinates, if that was the kind of style of the question, it might say where do they intersect, you could. That's your x coordinate, that's your y coordinate, that's your x coordinate, that's your y coordinate. Okay, and if we then go back to the diagram I drew at the top, then this one here is going to be our smallest ones, so that's going to be minus 5, minus 2, and this one here is going to be our top ones, which will be 2, 5. So in my very rough sketch, that is what we have worked out. Okay, now things to note. When you get to this point, it could be any kind of quadratic that you have to solve. So you might have a difference of 2 squares. You might have one that doesn't factorise, and don't forget, if it doesn't factorise, we are using the quadratic formula, okay? But the process is still the same. We're trying to find out our values of x. Once you find your values of x, you substitute them into the values of y, okay? I'm just going to quickly run through the steps again. So you've got a quadratic, you've got a linear. You take your linear and you make it either x equals or y equals. Sometimes the question will already give it to you as x equals or y equals, so you don't need to worry. You substitute your linear into your quadratic. So here we're substituting our straight line into our circle. So wherever we see a y, we're writing x plus 3. If we'd have made it x equals, wherever we saw an x, we'd be writing y minus 3 it would have been. Okay? You then expand it, tidy. It's a quadratic, so it has to equal 0. Then you have to either factorise it or solve it using the formula, or use any method you have of solving quadratics. Get your two values of x, or it would be y if you did it the other way around, and then substitute it back into the linear to find your other two values of x and y.